Hello guys, welcome to the DMS online school. In today's video, we are going to do a revision which is for chemistry paper 2, pure chemistry paper 2. So this video is going to be on pure chemistry paper 2. Okay, so this is for pure chemistry paper 2 revision, and to begin our revision we are going to look at a question which came from a topic. Actually, the topic that we are looking at is electrochemistry. So I'll be revising a question from electrochemistry. Okay, so we'll be looking at electrochemistry, which is just under pure chemistry. Okay, so the question we are looking at came in 2017 paper, and this was question 11B or B11. So the question was like, A, you are provided with a sample of copper 2 carbonate, green powder, and any other suitable chemicals and apparatus. Describe with the aid of a labeled diagram how you can obtain copper metal from the copper to carbonate. Write down the chemical equations for the two reactions leading to the formation of the copper metal. Okay, so this one is just an application question which wants you to apply different types of reactions like reduction reaction, decomposition reaction. Okay, so this is what this question is coming to test you about. So maybe to answer this question, you have copper to carbonate. So we have copper to carbonate. So they want from this copper to carbonate, you come up with copper metal. So they want you to describe. So the first thing you are going to do thermal decomposition of carbonate. So you can say copper to carbonate is heated, either you can say in a combustion tube, to form copper 2 oxide and carbon dioxide. Okay, so that's what happens when copper is heated. It undergoes decomposition to produce two compounds, which is copper 2 oxide and carbon dioxide. So this equation is here. So the equation is you have copper to carbonate. So this one is a solid. So it undergoes thermal decomposition. You heat it here, then you form copper 2 oxide, which is a solid, plus carbon dioxide, which is a gas. So this is the first process that can be done. Then the next process is that either carbon or hydrogen gas. So here hydrogen gas is passed over. copper 2 oxide in a combustion chamber to form copper and water. So we can say that hydrogen gas is passed over copper 2 oxide so it's passed over copper 2 oxide in the combustion tube. Here I didn't put the tube. In the combustion tube, so that it is reduced to copper metal and hydrogen or water. Okay, yeah, so that is that. So the equation here is this. So here is the equation. You write like a copper oxide, which is a solid, is reacted with hydrogen gas, then it forms copper solid metal plus water. Okay, so let's see if the equation is balanced. One copper atom, one oxygen, two hydrogen. Yes. Then this is the description, right? Then you can draw the diagram. Let me see if I can draw the diagram. Here, let me open a new page, an empty page. Okay, yeah. So the diagram that you can draw is a combustion tube like this. This is a combustion tube. A combustion tube. So in this combustion tube, so here you indicate hydrogen in. So here it's hydrogen gas in. This is a rubber band enclosure. Then also here you do the same. Okay. Okay. Then here you send excess hydrogen out. So excess hydrogen will come out. Then here you do like this. You label this is copper 2 oxide, and then here you can say, you can just put an arrow here, even an arrow like this, then you say heat. That is all. Then this one you can label it as a combustion tube. Oh, sorry. Combustion tube. Yeah. So this is the experiment. Yeah, for this question, let's get back. Yeah. So yeah, this is the question. So we are done 6 marks. 6 marks. So those are the two equations. Then we come to B. B says the diagram below shows an experiment which a learner carried out in order to purify copper metal. Okay, so this is an experiment which a learner carried out in order to purify copper metal. So we have a battery here actually. this side of the battery with a short bar, it is actually negative, and this side with a long bar, it's actually positive. Okay, then this side which is connected to the negative, it is the cathode. You need to know that. Then this side connected to the positive, it is the anode. Okay, so I've done that in advance. So then we have electrode A and electrode B. Then we have electrolysis, electrolyte C. So let's move to the question. So the question says, Roman numeral 1, which electrode A or B is the impure copper? So which electrode A, this one, or B is impure copper? So for you to know this one, it's quite simple, but sometimes if you have forgotten, if you know especially what electrolyte is used here, the electrolyte used in the electrolysis of copper is actually copper 2 sulfate, acidified copper 2 sulfate solution. This is the electrolyte which is used, and when electricity is passed through this electrolyte here, this copper decomposes, copper 2 sulfate decomposes as follows. So this copper will decompose to give us copper ion with positive charge of 2 and the sulfate ion like that. So this is the decomposition which occurs there. Now, the moment this decomposition occurs, this copper, which is positively charged, is attracted to the cathode, which is negatively charged. Why? Because it is connected to the negative part or terminal of the battery. So it will be attracted here. So if it is going to be attracted to the cathode, it means that it should gain some electron from somewhere. So those electrons that it should gain must come from this anode here. Those electrons must pass through the external circuit to the cathode so that they are gotten to form copper. So it means that during the purification of copper, the impure copper, like they have said in Roman numeral 1, like which electrode A or B is the impure copper. So the impure copper then must be placed at the anode. So in answering the question like 1, Roman numeral 1, when they say which electrode A or B is the impure copper, we can say A. Okay, so they place it there. So that what happens here is that at the anode, the reaction which happens at the anode is this one here. Copper dissolves in the solution so that it forms copper ion and loses 2 electrons. Actually, at the cathode here, at the anode, copper loses 2 electrons and then it dissolves as the ion go in the solution so that these ion, they travel this side. Okay, so those electrons will travel in the external circuit. When they reach the cathode, those electrons will join again with the copper to form the copper atom. So this is the reaction that happens at the anode. What I've showed you here is the reaction at the anode. Sometimes they can ask you, so anode. Sorry, let me just do it well, anode. Yeah. Then at the cathode, sometimes if they've asked, at the cathode, what will happen is this. At the cathode, the copper ion that had gone there will gain, each copper ion will gain 2 electrons to form the copper metal. So this copper metal will be deposited here. So the cathode will begin increasing in size, while the anode will begin reducing in size, because copper will be transferred from the anode to the cathode, leaving any impurities at the below the anode here. Okay, so yeah, so we have answered one. The answer is A, just like that. I've just explained these. Then yeah, so let me remove these which I used to answer here. Okay. Okay, let's see how we can remove these which are down here. Okay, so here again we go to Roman numeral 2, which says name a suitable electrolyte C used in the purification of copper. Okay, we have already mentioned it here. So the suitable electrolyte is already mentioned. So like 2, the suitable electrolyte is acidified copper 2 sulfate. Copper 2 sulfate solution. Then we go to Roman numeral 3, state one physical property of copper and give a reason why copper has this property. Okay, so 3, one physical property of copper is that it is a good conductor of electricity. So we can say copper is a good conductor of electricity. Because it has delocalized electrons which carry charge. Because it has delocalized electrons which carry charge. Okay, they carry charge or produce electric current. So what we can do, yeah, that is all here. Then there's another question which came in 2016, this one here. So this one is also coming from electrochemistry. So this question was A6, says the diagram below shows an electrochemical cell made using zinc and iron dipped in dilute sulfuric acid. Okay, so this is an electrochemical cell which is made by using zinc and iron which are dipped in dilute sulfuric acid. So these are the ones. We have zinc and then we have iron there. Then we have dilute sulfuric acid like that. Okay, so now let's see what the question is. So question A says, what is the overall energy change which occurs in the electrochemical cell. So does this represent an endothermic or an exothermic process? What is the overall energy change which occurs in the electrochemical cell? Does this represent an endothermic or an exothermic process? Okay. So in an electrochemical cell, the reaction which happens there, or the energy change which happens there, is chemical energy changed to electrical energy. So whenever this circuit is complete as it is, there's a current which is of voltage registered by the voltmeter here. Even when there's no battery here, the different metals which are used with different potentials generate electricity when they are dipped in an electrolyte like that. So they'll generate electricity which is going to be registered or read by the voltmeter. So that will mean that it's a chemical reaction which has got a chemical energy that causes electric energy to pass here. So there's a change, chemical energy changes to electrical energy. So when they say, does this represent an endothermic or an exothermic process? We can say it represents exothermic process. So it represents an exothermic process. Why? Because heat is given or energy is given out from chemical energy to electrical energy. Then we come to question B. They're saying to increase the voltage of the above cell, either the zinc rod or the iron rod can be replaced by another metal rod. Name a suitable metal which can be used in place of Roman numeral 1 zinc rod, Roman numeral 2 iron rod. Okay, so for their electricity to be produced here, there must be two different metals of different what I can say electrochemical potential. So these elements or metals must be of different potential. Okay, so like when we look at the reactivity series is also similar to the electrochemical series. Okay, so the wider the metals are from each other in the electrochemical series, the more electricity they produce. Like if we were to increase the voltage, we must make sure that we use a metal which is more reactive than zinc, okay, in the electrochemical series, which is higher than zinc in the electrochemical series. A metal like magnesium here can be used. Then to increase the potential, so we can use a metal which is more lower in the electrochemical series than iron. So here we can use either tin or copper. Copper can be used so that the more gap is there in terms of arrangement in the electrochemical series, the more voltage is produced. Then here they are saying, see, write an equation for the reaction occurring at the ion electrode. So like we write an equation for the reaction occurring at the ion electrode here. So here they already even gave us bubbles of hydrogen gas. So since they gave us even bubbles of hydrogen gas, it means that it is actually hydrogen gas coming out. They even gave us a clue. But what happens here is this. During electrochemical reaction itself, it's a spontaneous reaction because it is just not caused by any other external factors, but it is just caused by difference in electrochemical potentials. So because of that, then electricity is generated. So now, what happens is this. The more reactive metal tend to become positive, or negative. So this side becomes negative and this side becomes positive. So this one becomes like this one becomes more positive. So now what happens is this. This one now is called the cathode, in where electrochemical cells are concerned. Then this one is the anode. Now here is the situation. This one loses electrons. Zinc is like this. So it will lose electrons to form zinc ion plus those two electrons. So those two electrons will travel in the external circuit, come this side. They'll come all the way up to here. When they come here, they must be gained by hydrogen. Hydrogen will come from where? From sulfuric acid. So hydrogen will behave like this. I mean, sulfuric acid, which is like this, undergoes electrolysis and is split to hydrogen and the sulfate ion. Now what happens is that this hydrogen is the one which gains those two electrons. So hydrogen gains an electron to become hydrogen atom. So two hydrogen atoms combine to form hydrogen molecule. So you balance by putting a 2 here to balance hydrogen. You also put a 2 here, and also you put a 2 where? Here, like that. So this is the actual, no, you don't put a 2 here. Yeah, so that is how it is. Yeah, so now in terms of now answering this question, that is the equation they wanted here. So you write the equation as H plus. So you can, did they say you include the state symbol? No, you just say H plus an electron there, then you get hydrogen gas. Of course, this one you need to put a 2 there and then a 2 there. Yeah, so this is how you answer. So guys, thank you so much for watching. If you enjoyed this video, give it a like, and also remember to subscribe and also comment in the comment section. For now guys, bye and see you in the next revision. Peace.